Welcome back. In this submodule, we're just going to spend a little bit of time reviewing things we've studied before. We're going to go and look at function algebra again. This is considered so essential by the CLEP exam, I think it's worth reviewing. So we'll discuss again composition of functions in particular. So recall that, of course, I can do simple things with functions like add them, multiply them, and divide them. But I have to remember that g of x should not be equal to 0, otherwise I have division by 0, and that's bad. The main thing I want to review is this notion of composing functions. So in this case, I start with a point x, and I first apply the function f of x. And then I apply the function g of x to acquire g of f of x. Instead of thinking of this as applying two functions iteratively, I can think of applying one function. What is that function? Well, it's the composition of g and f in this case. So this is the kind of picture you might have in mind for compositions of functions. G composed with f just means first apply f and then apply g. So it really is just this kind of triangular or commutative diagram, it's sometimes called in mathematics. So, and also I would like to call to your attention that this is not the same as applying g and then f. That in general, composition does not commute. Order matters here. So it's more like division and subtraction than addition and multiplication. So we're going to look at different function pairs and compute f composed with g and g composed with f. So this will be a good exercise in terms of thinking about composition, and will also be a testament to the fact that f composed with g is almost never equal to g composed with f. So let's look at f of x equals sine of x and g of x equals x squared. So we'll start with f composed with g. So this is equal to f of g of x. So I would say let's plug in g of x, which is x squared, and then plug in that into f. So sine of x squared. So in this case, the picture is x first goes to x squared, and then goes to sine of x squared. Now, g composed with f of x, on the other hand, is g of f of x. And what is this? Well, this is g of sine of x. So sine of x all squared, which is sometimes written sine squared of x. So in this case, x first goes to sine of x, and then goes to sine of squared of x. So in general, these are not the same. Let's look at another example. So first we'll do f composed with g of x. So I'm looking at f of g of x. So f of x cubed, which is e to the x cubed. And now we'll do g composed with f, so g of f. So first I do f. And then I apply g. So I have e to the x to the third. So let's remember our exponential rules. What happens when I iterate exponentiation? Well, that's the same as doing one exponentiation where I multiply the exponents. So this is e to the 3x. So in fact, in this case, we can clearly see the difference. In the first example, I cube x and then exponentiate. In the second one, I just multiply it by 3 and then exponentiate. So really, the two compositions are very different in this case. And as a last example, let's look at an example with logarithms and absolute values. So f composed with g of x is equal to log base 2. It's too fast. This is f of g of x. So f of absolute value of x, which is equal to log base 2 of absolute value of x. How about g composed with f? Well, this is going to be g of f of x. So g of log base 2 of x. So absolute value of log base 2 of x. So again, quite different functions. In particular, the first example, f composed with g, is defined for negative numbers. Because first I take the absolute value, which switches it to positive, and then I can take the log of it. The other one is still not defined for negative numbers. So in some cases, composing in different orders drastically changes the domain and range.